Good morning, and welcome to another wonderful day in the world of chemistry. And I'm your hostess, Mrs. Robinson. And making her debut is, it looks like Penny. Yeah, there she is. There is the infamous Penny behind me, mascotting on her bee. All right, so what we are doing is we are reviewing solutions. So part one was kind of like a little intro of this week of what is going on. And part two now is going to cover a little bit, we're digging in a little bit more into the whole concept of more the mathy part of it, I guess you could say. And we're talking about concentration. And we were talking about, we know that the amount of solute ratio to solvent, that is what defines the concentration. And it can be subjective, which is kind of like an opinion thing, you know, what you might think is strong lemonade, I might not think is strong lemonade. I don't know, you know, it's one of those things. Or you can actually calculate it. Oh no, I'm saying the C word of calculate. Okay, it's not that bad. Calm down. I know, it's hard. All right, so I'm wanting to bring your attention to the board and this beautiful, beautiful question. Yeah, that just sounded so horrible. But I'm about to old school. Let's get one of those super fancy, expensive document cameras. Yeah, no. All right, so here's Mrs. Robinson's fancy document camera. I know, right? Pretty awesome. Yeah. All right, so my intention is to walk you through one of these cutesy little problems. So let's look at this first problem, talking about the concentration of a methanol solution, which is a variant of alcohol. All right, type of alcohol, if you will. And we're going to go through the steps, right? I know, isn't this awesome? How about I do this for right now? I'm going to just kind of do this for right now. Let's go through the steps, shall we? And what are those steps? What is step one? Step one is read the problem. The concentration, molarity, of a methanol solution produced when 0.2 liters of a 2 molar solution was diluted to 0.4 liters is blank. Oops. All right, well, let's double check our work. Yeah, because technically I kind of gave you the answer there. But on both, I gave you the answer. But I want to show you my steps, okay? Let's look at the steps. So there is the formula, right? It's a ratio. This looks just like Boyle's law. If you remember Boyle's law, where it was just kind of like those two things in this ratio format, right? There it is, right there. All right. So we read it. I wrote down the formula. What's the next step? Next step is write down what we know. What do we know? Well, I know that we were given a 0.2 liter solution. I know that it is 2 molar. And then I know we're going to dilute it to 0.4. Yay. All right, now let's do this. No, don't look at me. No, I'm just kidding. I'm okay with it. Fancy document writer camera. Here we go. All right, let me scoot that down a little bit so you don't have to look at my double chin. Yeah. These are the times, my people. These are the times. All right. So, formula. What we know. Oops, I forgot to put units. Don't forget your units. All right. So, what do we do now? We plug and chug. Plug and chug. Plug and chug. Hey, guess what? What do you think that M stands for? So here's just my point out the obvious. Ready? This right here, it's kind of given right there. Yeah, no surprises. It's exactly what you think it is. V, again, no surprises. V still stands for volume, guys. And last I checked, we still measure volume in liters. So what do? We plug and chug. You just plug in the numbers. So M initial, that's that 2 molar. V initial, 0.2 liters, equals M final. Oh, trick question. We have no idea. That is our question of the day. V final. Oh, yeah, that's right. It is our 0.4. Okay, can we go from there? Absolutely. Multiply these two together, and you end up with, don't forget you also multiply the units together. Now what? Divide this side by 0.4 liters. Divide this side by 0.4 liters. And then what do you get? Hey, looky there. It's exactly what I got on the screen, isn't it? Yeah, I know. Work at home, Mrs. Robinson, is not quite as glamorous, is she? So that, my friends, is how you do a dilution. It is just a ratio. It's just plug and chug. There's nothing to panic over. I'm cleaning my magic board, my magic document camera board. Okay? And the only other thing I want to point out is look at the vinegar one. I laid it out for you just like I did on the board. However, I do want you to notice the meme. Please notice my boomer meme. One of these things is not like the other. Can you spot it? I can spot it. Right there. Fill. Fill! Yeah, no, not that kind of fill. No fill. Outline. Let's go red. Red's my favorite. See it? Yeah. See the milliliters? Spoiler alert, we get to bring in our old friend, King Henry. King Henry died by doing crystal meth because remember, kids, drugs are bad. Yeah. And all I did, the little tiny little extra step here, is the fact that we have to convert milliliters to liters. Ooh, yeah, not that scary. All right. So that is my beautiful, beautiful introduction to dilution. Okay. There's a couple. All right. There is a couple on it. Okay. Which brings me to definitions. You guys should get this. Okie dokie pokies. You start with a solvent. And what is our universal solvent? Water. Yay. Okay. So you start with your universal solvent. And then we're going to add some sugar. Right? Okay. So as we start adding the sugar, our solution, if you will, would be called unsaturated. UN. Keep adding sugar until you hit that super perfect sweet spot, that point, if you will, that saturation point, where the perfect amount, the greatest possible amount of sugar solute is dissolved. It is a point. Okay? That's the sweet spot. Now the solution is saturated. Add another teaspoon of sugar. Oh, look what happens. You keep stirring, but that sugar just keeps floating to the bottom. Oh, you went over. You super saturated it. Is there a way you could fix it? Why, yes. Yes, there is. And what can we do? Let me hear it. Scream at your TV. How do we make perfect sweet tea? That's right. You heat it up. Heat it up. All right, I got 1 minute left. Yeah, I know this is one fun thing about these. But again, bite-sized pieces. All right, that's what we want. All right, let me scooch myself up here. Okay, so you can see. All right. Now, last thing I want to cover in the last 2 minutes, electrolytes versus non-electrolytes. You can read a slide. I'm assuming you can read a slide, right? Okay. Here's the cool thing about electrolytes versus non-electrolytes. Basically, spoiler, surprise, electrolytes, when they dissolve in water, allow for electrical conductivity. Why? Because they are ionic compounds. They tend to be salts. And what happens? Those ions separate, allowing for the electrons to flow. Because what happens when ions separate? You end up with a cation and an anion, and they have charges. So, surprise, when you actually do this in for reals, yeah, you can actually try this at home if you really, really want to. But I can send you a video. But when you actually add salt to water, you can run electrodes through it, and ta-da, the light bulb will actually light up. Versus sugar, because sugar is a covalent. So what's ionic again? Metal and a non-metal. Remember, metal, non-metal, ionic. Isn't it ionic? A non-electrolyte, when dissolved in water, does not dissociate. It does not produce ions. Okay? No electricity. All right. So, thank you guys for showing up. There is part 2 of the test in the bag